Vanakkam. So, in this class, we are going to discuss about ionic equilibrium. Ionic equilibrium, right? See here, it is in NCERT syllabus, it is in 11th standard. Okay, whereas in Tamil Nadu State Board syllabus, it is in 12th standard. Okay, clear? So, what is ionic equilibrium? It is nothing but the equilibrium involving ions. Equilibrium involving positive and negative ions. How it is? What is it actually? We will see. See here, consider sugar solution. Sugar is dissolved in water. Consider at the same time salt solution. Right. The sugar solution will not conduct current. So Michael Faraday is the first person to discuss all these things. Michael Faraday. So he noted that the sugar solution it shows no conductivity. So he called this type of solutions which do not conduct current as non-electrolytes. Okay, non-electrolytes. At the same time, consider the salt solution. It conducts current. Further, the conductivity depends upon concentration. Conductivity depends upon concentration. If the concentration of the salt is more, the conductivity is also more. So he named such solutions which conducts current as electrolytes. Okay, right. Further, he classified those electrolytes into two types. One is called as strong electrolyte and another one is called as weak electrolyte. Okay, sir. What is meant by strong electrolyte and what is meant by weak electrolyte? He noted that when 1 mole of some salt is dissolved in water, example, sodium acetate or HCl simply. So when 1 mole of any substance is dissolved, it will produce same number of ions. 1 mole of any substance will produce same number of ions. Is it Avogadro number, right? So some solutions which are showing more conductivity and some solutions are showing less conductivity because of the dissociation of the ions. So the solutions which show complete dissociation, they have more conductivity and he called them, Michael Faraday called them as strong electrolytes, right? One solutions they show partial dissociation. So there the same 1 molar solution, the conductivity here is more. For the same 1 molar solution of some other salt, the conductivity less is because of the partial dissociation of the ions. He named those electrolytes as weak electrolytes. Okay, clear? Example, let us see an example. For example, 1 molar hydrochloric acid, it will dissociate into 1 molar H plus ions and 1 molar chloride ions. Okay, 6.03 23 H plus ions and 6.03 23 Cl minus ions. Adhuve or weak electrolyte. Similarly, if you consider a weak electrolyte, example, acetic acid. Here, what is the arrow mark I am using? Note it. It is equilibrium. That is reversible reaction. So it will produce lesser number of acetate ions and H plus when compared with 1 molar, that is 6 Avogadro number of ions will not be produced here. Okay, so you must be very clear that strong electrolytes undergo complete dissociation and weak electrolytes undergo partial dissociation, right? Now see here. So we discussed ionic equilibrium and so now what is it? Equilibrium involving ions. How ions are produced? It is nothing but due to the salt. So the salt, example, sodium chloride, it gives Na plus ions and Cl minus ions. Our question is how salts are formed first. So when an acid reacts with a base, the reaction is called as a neutralization reaction. And the reaction is neutralization reaction. Now what is an acid and what is a base? That is the next question. So acids are substances which produce H plus ions in water, which produce is generally we know that they are the substance which produce H plus ions in water. They turn blue litmus to red. So what are bases? Sir, they generally give the OH minus ions in water. They turn red litmus paper to blue. Then, so acids generally they liberate hydrogen gas. With metals. Generally with metals, acids liberate hydrogen gas. Here no such reaction is observed. Acids have sour taste. So their bases will have bitter taste. Then another important aspect of the base is they are soapy in nature. Soapy means okay, viscous, right? Then acids, example, we can say HCl, which is responsible for the digestion in our stomach daily. Citric acid is present in lemon, right? Ascorbic acid is present in orange and some other things. So these are all the acids present in natural sources, right? Base. Example for base is nothing but the washing soda, which we generally use for the washing purposes. Okay. Now we will discuss what is acid and what is exactly a base. Clear, right? So an acid is explained in several variations by several scientists depending upon the conditions. See here, generally acids are substances which gives H plus ions in water. So bases are the substances which gives OH minus ions in water. Example, you may say hydrochloric acid, and example you may say sodium hydroxide. See here, we are generally discussing in other lessons that ammonia is also a base. But this Arrhenius concept it doesn't give any explanation for why ammonia is a base. So according to this concept, those substances which give OH minus ions in water are called as bases. But ammonia is a base. There is no explanation for Arrhenius concept. This is the main defect of Arrhenius concept. Another defect is that Arrhenius concept deals with only aqueous solutions. Aqueous solutions means what? The solvent is water. It does not deal with non-aqueous solutions, right? Then, so in order to rectify those defects, next concept, Lowry, Bronsted, the two scientists, they give a concept. What is the concept, sir? Means they mentioned acids are substances which gives H plus ions to others, which donates H plus ions to others. Example, the same hydrochloric acid, sulfuric acid, etc. Right? What are bases? According to Lowry, Bronsted concept, bases are the substances which accepts H plus ions, Example, this ammonia, it can accept an H plus ion, and it will form ammonium ion, In such case, it is termed as base. Then, further, there is no explanation that BF3, boron trifluoride, aluminium chloride, these substances are behaving as acids under certain circumstances. There is no explanation why they are behaving as acids by these two principles. So, another concept, Lewis developed another concept. According to him, all electron acceptors are acids. Or electron, you may simply note it as A for acceptor, A for acid and A for acceptor. So electron acceptors, all electron acceptors are acids, and all electron donors are bases. Example, OH minus ion, it donates electron. NH3, ammonia, it donates the lone pair of electron to others. So acids are substances which accepts electron, and bases are substances which donates electron. See here, why it is accepting electron means boron, valence electron of boron is 3. Okay, it forms 3 bonds with fluorine. See here, let me explain with bond nature. So this is the configuration of boron. So now boron has 6 electrons in its valence shell. To become stable, and a species need 8 electrons, right? Octet rule, we know that. Okay, so in order to fulfill the octet, it accepts a pair of electron from this ammonia. So ammonia has electron donor, which is base, and BF3, boron trifluoride, acts as electron acceptor, which is called as Lewis acid. So they form a compound. With coordination bond. This is a type of salt. Acid and base reacts to form salt. Okay. Now I think you are very well clear what are called as acids and what are called as bases. I think you are all very well clear with that, right? Further, there is some more concept in this, right? According to Arrhenius, those substances which give H plus ions in water are called as acids. Similarly, OH minus ions in water are called as bases. See here, H plus, it is called as proton, isn't it? Okay, it is a highly reactive species. So in water, it will be, since it is highly reactive, it combines with water, it will become hydrated and it will be existing as hydronium ion. So what is the name of this ion? Hydronium ion. So it is having a trigonal pyramidal geometry. So since 3 bond pairs with 3 hydrogens and 1 lone pair is there in oxygen. Okay, leave it. Then another important point we have to keep it in mind is in Lowry-Bronsted concept, those substances which give H plus are acids, which are accepting H plus are bases, right? Consider an example. HCl when it is dissolved in water. See here, HCl gives H plus. So it gives H plus. So it is called, it comes under the category of acids. So it is called as an acid. Right. It gives H plus to water. So water accepts H plus here. So it is called as base here. Right. Then after giving H plus, the remaining is Cl minus here. And after gaining H plus by water, the remaining is H3O plus here. Right. Similarly, suppose if ammonia is dissolved in water, what ammonia does is it accepts H plus from the water molecule. So since it accepts H plus, it is called as base. Water gives H plus here, so it is called as acid. So it is called as acid. Right. What happens? After giving H plus, water will be existing as OH minus, and after gaining H plus, base gains H plus, right? So it will be existing as NH4 plus. So an important point is here. Note it down. So when we remove a proton from an acid, it is called as conjugate base of that acid, of this acid. This is the conjugate base of this acid, right? So when we add a proton to a base, it is called as conjugate acid of this base. So this is the conjugate acid of this base, and this is the conjugate base of this acid. Similarly here, base, when we add H plus is kuda senda. So idhukku per enna? Conjugate acid, and this is the conjugate base of this acid. Okay va? So idhukku per conjugate acid base pair appdin per, conjugate acid base pair appdin per. Clear? Next, what is the difference between a base and conjugate acid? It is nothing but a H plus ion. Only one proton is different. See here, the difference between this base and its conjugate acid is a proton. Right. Next thing, if an acid is a strong acid, then its conjugate base will definitely be a weak one. Right. Similarly, if a base is a strong base, its conjugate acid will be a weak one. So vice versa. A strong acid will produce a weak conjugate base. A weak acid will produce strong conjugate base. So it is a vice versa concept. You must all keep it in mind, all these points. Right. Another one thing here. Here water acts as base in this equation, in this reaction, and water acts as acid in this reaction, because we have already studied water is an amphoteric oxide. What is an amphoteric oxide? It may act as an acid or it may act as a base depending upon the condition or the reactant with which it is present. Clear? So these are the things which you must keep it in mind when we are discussing about an acid or a base. Okay, I hope you are all very clear with these concepts. Thank you.